Will you be able to use ranges like in the for loop? No, not right now. And I'm not sure if people can provide enough of a use case for ranges, then that might be the version of like less than and greater than that actually makes sense. Because the thing about ranges is it's easy for the compiler to test if they overlap, right? If the ranges are statically known. And that means that you can complain about the user trying to do a duplicate case or whatever, right? Whereas if you have a bunch of greater thans and less thans in there, then order seems to matter. Unless you bake them down, unless you do some kind of analysis to bake them down. Probably some languages have done that. I don't know which ones. Anyway, so the answer is you can't use ranges like that, right? So the question is just about this. The question is, can I do, case 8 to 15? And the answer is right now, no. In principle, you could. It just depends on how important we feel it is. For if case, why not make complete the default for enums and make presence of a default case indicate not complete? Because sometimes you want a default anyway, right? So default and complete are not exactly complementary concepts. And I mentioned it in a comment here, but I didn't verbally say it. So unless you were reading the comments. The point is, okay, so say I've got this and I mark it complete, right? And imagine that I actually had all the cases in here. I had my Johannes Beeren in here as well to make it complete. I still want a default case sometimes, because what if an uninitialized value gets in this variable or something, right? I don't want to not be able to express that, right? Just because I say this is an enum fruit doesn't mean it for sure has a valid fruit value in it, especially if I got it out of a network packet, right? Or if I just have a bug in my program. So you want to be able to have a default case no matter what. And if that magically turns off complete, then you're a sad panda. Can variables be used in the cases? Not if the variables are not known at compile time. This is for compile time constant expressions. This isn't for generating runtime if statements. Increment, decrement, yeah. Do you mean like, someone is asking about, do you mean like plus plus and minus minus? No, I don't have those, and it's possible I never will have those. Will external programs be able to access the compiler message loop, for example, in IDE? The idea is that you will be able to use the compiler as a library. Yeah, so and in fact, the main program of the compiler that you run would be a very thin container around the use of that library. So yeah, you'd be able to embed that in an IDE if you wanted to or whatever. Am I going to use this language for my next game? Yes, there's already a game in this language. I demoed it. If you look at my Reboot Develop talk in Croatia last month, you'll see a demo of that game. So someone says, I noticed assert doesn't tell you the expression that was false. Will there be a feature to allow that, e.g. stringifying code? Well, the thing is that I'm not sure how I want to do it, right? So right now, I could implement it probably in most cases just by using that source code location variable, right? Because I can open the file that the assert was in, and I can print out the context around the thing. I can print more than one line of context if I want. And that's useful, right? The thing that makes that not necessarily true, and that I have to think about, is, what if it doesn't have a corresponding file? So what if it's a string that was added to the program? Well, that can be echoed to a file, and maybe we give you that as the file name? I don't know. I have to think about that. In general, you want that location directive to do something intelligent in that case. And I think that currently, if you say location in one of those, it says the file name is just like open paren from a string, close paren, which tells you something about where it came from, but that's not enough information to like get that string and print it out. Anyway, so that could be one way to handle that. The other way, though, is to add a macro facility, but not preprocessor macros, but like more like Lisp macros or something, which I may do, right? And so what's happening then with assert is I'm sort of waiting to see which of those ends up being the better way to do it. And I don't know yet. We'll see. What's so bad about plus plus and minus minus? I just don't see the point. I don't know. I mean, I do a little bit want to use them sometimes, but not very much. And they're extra operators, but I don't know. We'll see. I mean, there's nothing preventing adding plus plus and minus minus. It's just that if you start out by copying C++, then you end up with a copy of C++, right? And so my philosophy the whole time has been, let me see how much I can go in another direction. That's why I didn't have a switch statement for like a long time, for years, right? Because it's like, okay, yeah, I could do that, but until I get to where I really find myself smarting from the lack of it, I'm not going to do it. So I didn't do it for a long time. And then I finally did it because I had so many times and I'm like, yeah, I'd rather do this as a switch statement. So that's all. I mean, if the language gets fully designed and it then makes sense to put plus plus and minus minus in there, then like, sure, we could do that. It's just they're not important. They're totally unimportant. Someone's asking, when nailing down the finished syntax, could you be tempted to include new weird symbols, you know, various UTF-8 or Unicode symbols or whatever? I've thought about that a little bit. I certainly don't want to make them mandatory. I don't know. I mean, sometimes it might improve readability to do stuff like that, but we'll see. I mean, I just don't necessarily see that really helping. Although once in a while I do get tempted to like, if I just used a little character here, it would be cleaner syntax or something. We'll see. Couldn't you metaprogram a case range that simply emits the case through for a range? Yeah, you could do that, for sure. The thing is, if a lot of people end up wanting to do that, then maybe I shouldn't force people to metaprogram that. Will the compiler be cross-platform? It already is. If you watch my reboot develop thing, we already have a screenshot of it running on Linux. Well, the whole game running on Linux. What do I think about Stali Linux or the idea of ubiquitous static linking? Does the era of modern cheap storage make it worth the trade-off in reuse? Does this idea have a bearing? Okay, here's what I think about static linking. Okay, one of the reasons I don't use Linux is because it's so faulty, right? It has so many problems. And one of the reasons it has so many problems is they have this dual bad idea of we're going to use dynamic libraries, and then we're just going to update the dynamic library. So we're going to update your libc, and you're not going to know, and you're never going to care. Well, actually, in reality, that breaks things. And that's far from Linux's only problem, but it's one of the problems, right? So what we know from shipping complex software in places like games is that if you want your software to work, you test exactly the configuration that ships. And then if something is going to change, if some library is going to change or some component is going to change, you have to thoroughly test that change. You don't want that happening behind your back. So first of all, static linking is better than dynamic linking in that sense, in that it produces more robust software. People can claim, oh, but dynamic linking enables you to fix bugs later, and maybe, but in practice, we've had a long time of that being the theory, and it's never fixed a bug in any program that I ever shipped, so it sounds very theoretical to me. In fact, it's only ever caused problems. So there's that. Now, that said, static linking is not required for that. You could just have discipline and say, once we ship a dynamic library, we're not going to change it. But people don't seem to be willing to have that discipline. So I think if you want robust software, either you have to statically link it, or the dynamic libraries have to be yours, and the only person who would ever rebuild them is you. And then when you rebuild them, you thoroughly test just as thoroughly as when you shipped originally. What does the error message look like for the switch if I meant to write an if statement but forgot to the second variable? Well, let's see. I don't know. So you're saying the question is, I believe, let me just go down to the bottom of main. So I'm going to say x is 5 if x is equal, just for now, I'm going to say if x is equal to 5. Right, so this is the well-formed version of what I believe the question is. So let's make sure that where's my, oh, complete. Right. Okay, so 5 is what we printed. So I believe the question is, what does the error message look like if you just forget that? I don't know. Okay. Only case statements can be inside an if x equals open brace. So that at least tells you that the problem is maybe that there's nothing on the right side of the equal. And then else without if. So I don't know if that's a good enough error message. It seems okay for now, and then we'll see how it goes. Have I considered making switch complete the default and using a keyword for not complete? The thing is that complete only makes sense for enums, and you might switch off other things. So like complete for strings doesn't make sense. And so changing the default is maybe not that good of an idea. Although again, we have to see, right? If this way causes bugs, then in a future version of the compiler, we can change that semantic, because we're not doing this in the C++ way where we freeze things forever. Yeah. We'll talk about that when I've talked about that before, so people who have followed a lot of these streams know what I'm talking about. Can through be used to redirect a case to a non-consecutive case in the switch statement? No, it cannot. I think if you really wanted to do that, you would have to use a goto, and I haven't implemented goto yet, so there is that. Quick question about relative pointers. How about declaring a pointer as a relative pointer to relative memory, relative pointer to absolute memory for controlling the effects of copying the pointer? How often do you use one struct with both? Yeah, I mean, we could introduce something like that. It's just that before I add more complications like that, if ever, then I want more experience actually using a feature like that, which I don't currently have. Right? Any time that I've done that neighborhood of thing in programs in the past in a language like C++, I would, just have a number in a file that I manually add to a pointer or something, right? And so once it becomes a language feature, I have to use it for a bit to get experience with it before I know where to go next. Like there have been some other facilities. So like Boost, which is I think a somewhat commonly used but completely bananas library for C++. They have a relative pointer there called offset pointer, but I've never used that. And I think other things about C++ would make that less convenient to use anyway. So I don't know. I just have to see how it works out. Are these called case if now since switch is no longer a keyword? I don't know. I just say switch, but you could call it a case if you want. I hadn't thought of that name for it. That's probably fine. Yeah, I suppose one other thing we could do is in the build options, when you start the compile and you set the debug level and all that stuff, maybe you can set an option about whether complete is the default for enums or not. That might be the way to handle it. I don't know. I haven't thought about it enough. Can structs with parameters take struct or string parameters? Yes, they can take anything in the universe. Well, is that true? They certainly can take strings and any kind of number. The question is just if they can take structs yet, but I believe the answer is yes. I believe they can take anything representable in the language. We'll see. If you use an if case block, could you follow that with an else or else if? Well, I didn't want to confuse those things right now, so the current answer is no. Because that's what a default case is for anyway, right? Default case, and maybe, right, I mean, maybe this should just be else. Because that's what the default case is. And maybe I shouldn't confuse it yet by putting else. Maybe it should it's just going to be case for a while. But, I mean, if you have a default case, what else do you want out of an else? Maybe I'm just not thinking of it. Do I think I would ever allow goto? Yeah, I mean, I think if you want goto, then if you want to put goto in a language like this that has like defer and destructors and stuff, then you have to handle exiting scopes cleanly and entering scopes cleanly, right? And so, well, of course, you're going to skip initializers in scopes probably. I don't know. The exact policy for goto would have to be decided. Certainly, it would probably exit scopes cleanly. But whatever, whatever behavior it would have here would be analogous to what it would have in a regular procedure if you just had some nested blocks with some code in them, right? It's really not any different. Can I rant about programming related things I want fixed? I don't know. I mean, I'm doing what I can to fix things. I can only do so much, right? There's so many things that are broken and people have really low standards. It's the fact that people have really low standards for how good things should be, honestly, is the problem. It's like, we're standing on the shoulders of giants on some structure that's slowly decaying. It's like we lost some idea of materials engineering about software, and so the things that we build over the time are getting worse and worse. I've given this rant before, and I'm a little tired today, so can you defer a block or a lambda? Yeah, you can do all sorts of stuff. So at main At the start of main, I'm going to say defer, y is 5, print, this is the end of main, while y, print, y is, right? So y is 5, 4, 3, 2, 1, right? So I can defer that whole thing. Oh, and that happened at the end of main after all these other things, right? Which is why there's a defer there. Could I do something like if check and A is equal to something to short circuit? No, not right now. That just seems like an uncommon thing. I mean, you would just put an if else and put your other case if in the else, right? It's the same. And see, you can break out of switches. Can that be done here? Oh, you mean like a break statement in the middle of the thing? I don't know. I don't know if I did that. I may not have done that. So like, I suspect this is going to give me an error. Yeah. Can only break from within a loop. So, I don't know. I mean, if that's important, we could do it. I'm not sure it's important. Like, I think that might be more of an artifact of the way the C++ version works, but we'll see. I mean, I'm obviously not, that's not, the presence or absence of that feature is not going to determine anything important about the language as a whole. So, you know, things like that. It's like having plus plus or not. It doesn't matter. Well, we support a for else clause. I don't understand what that's supposed to do. I guess, so is that like from Python or something? Like the else happens if you don't break out of the for? Is that, then why isn't it for then? I don't know. It's just not clear to me that I ever wanted to use that. So, I don't know. You would expect for less than 5 ... 1 to be the empty ordering. No. Wait, what? Okay, so here's the thing, and maybe there's a less confusing way to syntax this, or maybe there's a less confusing semantics for it, but basically, right, so the goal of this is not to switch the order of the two arguments here. There would be no point in that because you could just switch the order of the two arguments that you typed, right? If they're variables or whatnot, right? The goal of this is to take whatever range is represented by this and iterate over it. Oh, you know? Actually, it might be better. Yeah, okay. The better definition. I don't know. Okay. So the question is, what's the better analogy? So I only brought out this example because Well, the original motivation for this feature was just iterating over arrays or just individual things like that, right? Like iterating over numbers, I think, is less common, although you might do that if you had indexes to some array. And so I guess the question is, what's the best analogy of this? And it might be that the best analogy of this is what the commenter is saying, and that this just says, well, we're going to go over this same range but go backwards, right? Whereas right now what it says is for numeric iterations, our direction of iteration is -1, right? So because our direction of iteration is -1 instead of +1, then this one doesn't do anything because -1 is already on the minus side of 5, right? It just depends. I could see it being either way, honestly, and it would be a very small change. I guess the question is, what is less confusing for people? Could take a poll. Or maybe I'll see if I need to use that in the game sometime soon, because I haven't used this form of it yet. I've only used this form. And we'll see if I get confused by it and what happens in that case. Is there a rigorous difference between the semantics of @ and hash keywords? Okay, @ is not a keyword. @ is a note. So when you say like, @hello, the compiler does not interpret this at all. That's just for your program, right? It's a note on this declaration that your program can look at. So it doesn't do anything except what you make it do, right? This stuff is stuff that the compiler pays attention to, so it's different. Can the default case be further up or only at the bottom? Yes, it can be further up, and I guess I should have made an example of that. So I can put this in the middle, right? And it's still, well, let's, where is that? That's the hello. So we're still on Big Sailor, and if I change it, I should hit the default case. Yeah, I don't know what you're talking about. So that's fine. And if you put it through, it'll go in the order in which things are listed, right? So you might have a reason to put the default case if you want somebody else to fall through and do it, but not these other guys. I don't know. Are there plans to put common metaprogramming operations in the standard library? Yes. We want to make metaprogramming easy and robust. It's just we have yet to figure out exactly what those things are, because that takes time. Am I going to have optional functional purity checks? Yes. Is there a parallel in C++ that you use in order to get the defer functionality? Yeah, there's some really gross template plus constructor thing you can do now that I use that, I think it's been possible since C++ 15 or maybe 11. Anyway, I do use it in C++, but it's a little bit gross. Will there be any language level constructs for threading asynchronous code? People keep asking that, and I've been thinking about it. And so far the answer is no, because I'm not sure what would actually be helpful. Possibly there might be something where you say, this variable is associated with this lock, and so do error checking when I access the variable to make sure that the lock is held, right? The problem with that is, well, first of all, somebody could take a pointer to that variable from far away, and I don't know, maybe you prevent that somehow, but then that gets annoying. Or the other problem is just that serious multi-threading, that's going to be the most buggy anyway, is not really going to use mutexes, because mutexes are not, for hard multi-threading problems, they're not a particularly useful construct. And when you start doing like compare and swap type of things, because you really want to be fast and or have a relatively delicate multi-threading, there's not a lot that the language is going to help with at that point. So the more serious you are about parallelism, the less that'll help. However, it may be that having that help for beginners or for expert people who are early in writing their parallel code and who are just like, you know what, screw it, I'm just going to put mutexes here, or I'm going to have a debug compile build where I use mutexes even though they're slow because I want to be able to fall back to that to detect if I have a multi-threading bug, then maybe it's useful to have that kind of construct. But for the most part, no. Like when you look at a language like Go and they're like, oh, just use channels for parallelism or concurrency. God, that's a whole rant I have to do, is why that concurrency is not parallelism talk is not good. But, you know, like channels are not an efficient way to parallelize code. So any language that promotes that as the feature that they're helping you be parallel with, is not a language that is going to be very fast at writing parallel code, in my opinion. Someone said enumeration during for each is, i.e. having an index for each element. Yeah, I don't feel like that's that important. Eh. Oh, the else on the for would only execute if the for while doesn't ever execute. Is that really useful? Like, what do you use that for? Do these switch statements compile the jump tables or for integers? I mean, that's an implementation detail. Right now, they don't. Right now, I just compile them to if-else. You know, the classic thing you would do, since your enums are going to be a small number of integers, the classic optimization there, right, is to make a jump table. I haven't bothered to do that yet because I'm lazy, and also because I'm not really sure that there's a real-world performance benefit for that for most simple cases. Like once you're, you know, because the problem is your jump table is a relatively unpredictable branch. I don't know, maybe that's not true on newer CPUs. I need to, you know, I need to research it. Anyway, I mean, all I'm explaining is why I've been lazy about it so far, because I've got a lot to do and jump tables is nowhere near the top of the list. But it'll probably happen eventually because you probably want that optimization as a programmer. Am I aware of Rust's lifetime ownership and borrowing? Yes. Do I consider them good concepts? Maybe. Anything like it here? Maybe. So my approach is that if you want that kind of extra checking, then your metaprogram framework implements that. So you could do borrow checking if you want in your own external framework. And my goal is that the core language gives you enough information that you can implement those things. Have I thought about updating and improving the way comments work? A little bit, but not very seriously. Would I consider adding a by keyword to for loops? I find the surprising number of times I end up with loops that go up or down by 2. If the language doesn't support this, it makes it more verbose and error prone. Yeah, I mean, I probably will end up adding that. Like, the thing is, the thing that sucks when you have an advanced or a for loop feature is as soon as somebody, like, say you're using it for a little bit, and then you want to go by 2 instead of 1. Now if you have to fall out of the feature and rewrite it to be a while loop or something, you know, because we don't have C++ style for in here. So, you know, as soon as that happens, it kind of sucks, right? So, you know, I feel like iterating by n is common enough that there should be a syntax for it in the for loop. You know, with most things in the language, I am very averse to adding weird little features like that. But the thing is, if like programming for me these days is all about iterating over arrays. Basically, all I do all day is iterate over arrays in different ways. And so, like, having a robust for loop helps with that so much that I'm totally willing to add weird, wacky features to it, because it's one of the cores of the language, I would say, at this point, is iterating over arrays. Someone is asking, will you support a compiler option? Will it where if you don't exhaustively switch on a sum type like an enum, the compiler will kick you in the butt? I believe I demoed that and answered that question 5 times. Maybe you dropped in late. Or maybe I don't understand the question, but it sure sounds like you dropped in late. Am I ever going to work anymore on invaders? If I ever get an idea for what I want the game to be, I have a very abstract idea for what a game like that might be, but it's very far from reality. Like, I haven't completed the design in my head, so not really, maybe someday. Am I playtesting? Not really. I guess he means, am I giving the language out to other people to try yet? Not yet, but that'll happen eventually. Have I taken any inspiration from Nim? No. Everybody asks me about different various languages. I mean, I looked at Nim and determined relatively quickly that the goal of Nim is very different from my goal. And so it's probably not that productive to study the language in detail. And the thing is, if I'm going to get real work done, I just have to have that attitude, because there's only so many hours in the day, and I only type so fast. So, yeah. Have I looked at all the sort of fake, same thread, parallel stuff in C#, like resumable functions and coroutines? I have not. However, I'm not a fan of that stuff. The reason is the same reason that I have a beef with Rob Pike's concurrency is not parallelism talk, which is the following. Concurrency makes your program buggier and harder to understand. That's just how it is. So if you're going to do that, you should get a very big payoff for it. Very big. And the only real such payoff that you get right now is parallelism. I mean, unless it's concurrent by necessity, right? So a case of where you're concurrent by necessity is just like, you know, I've got a multiplayer game split across servers, and I'm passing an object from one server to another, and we're exchanging ownership, and that takes some time. But I have to keep running while that's happening, you know, so I don't stop servicing requests, right? In that case, that transfer of that object's authority from one server to another has to be concurrent. Well, it's also parallel, but that part doesn't matter so much. It's just to say, look, if you can write very simple in-order code to do the job, then do that, because it's going to be way better than if you try to write some bananas concurrent code. So if you're going to write bananas concurrent code, have a good reason. And that good reason is probably parallelism. I can't think of another reason, right? So for example, another example of quasi, you know, of concurrent-ish code would be using fibers, right? So, you know, I was reading D stuff a while back, like years ago now, because I was just trying to familiarize myself with what other languages were doing, and someone was making a D compiler that used fibers to keep track of all the different things in the compiler, and I know exactly why, because when you don't have header files and you're trying to manage dependencies between what can compile next and what can't, then you have this very out of order process happening. But I think attempting to do something like that with fibers is a huge mistake. I think it's a massive increase in complexity and a decrease in performance, and you're much better off doing it the way that I am doing it here, which is just plain old-fashioned code. You know in C++, how they added classes, and then classes have vtables and stuff, and so then they have this concept of POD, plain old data, for like what structs were in C. And in C++, whenever I'm working with plain old data, I feel good because I know exactly what my program's doing, and it's not weird and bizarre, right? So it's the same thing. There's this thing in my mind called plain old code, which is like when you're not doing something bananas and it's just linear control flow, and you don't have exception handling, and you don't have fibers or coroutines or any of that stuff. And that kind of code is very much more robust. It's very much easier to understand, and etc. So that is my preference. That said, who knows? If somebody makes a case that coroutines are awesome, you know, we might add them eventually, but I feel like maybe my job is to make the language robust enough that you could build coroutines as a higher level feature and that they just work, right? Because people have their own opinions about how coroutines should work and blah, 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 blah. But I don't, and then this whole idea like that Go has of like, oh, let's make a bunch of coroutines and some of them will be in threads and some of them won't, and like, blah, it's just, no, that stuff, for the kind of domain that I'm in, you don't want that. You want to know how many threads are actually, how many hardware threads you are using. And you want to schedule that stuff yourself because that's how you get performance. So, you know, I might be convinced of differently someday, but that is my opinion on the matter today. The white space in those cases is not significant, right? So there's an implicit sort of scoping brace here and there. That's all. But the white space doesn't matter. It's not Python. So Tyler's saying, well, it's, you know, not useful for heavy processing like a thread, but useful for spreading some function out over a lot of frames. I think if you want to spread a function out over a lot of frames and you don't want to introduce crazy, weird, hard to understand bugs in your program, then you need to write plain old code and have a reentrant function that you call every frame, right? Or every n frames. That's just my opinion on that. Or you launch it in a thread and you take the full bore thread situation. I just don't think that fibers and coroutines that aren't on separate threads and whatever are worth the complexity hit that you take for having them. But again, I think my job is to make it easy for people to build something like that in a library if they want to. So, yeah. Yeah, I mean, it's true. If we had the by keyword that lets you step by a certain amount, then saying by -1 would work, and then maybe it's not confusing anymore. That is true. So maybe we'll do that. Maybe not though, because you want to have the ability to say by n, where n is a variable, and then if n happens to be -1, you have the same problem where maybe that should just mean you don't iterate over the list. I should do a survey of what other languages do on this, because I think even going back to Pascal, languages have done this, and maybe people have come to a conclusion by now about how it should go. Someone says, is it possible that the preference for not requiring braces in case statements is C++ trauma manifesting? If they create real subscopes, shouldn't they have consistent syntax with other structures that create subscopes? It's possible, but I mean, this is my best guess at the right answer. I don't want to have to type braces everywhere, and consistency, I think, is valuable, but not when it creates tedium. And so I believe that this is the right answer, but we'll see. So also, though, you know, the reason why I don't just jump up and down and say, hey, I made a programming language, everybody download it from my GitHub and try it out, is because I want to make sure that when we release it, what we're releasing is the right thing. And so, you know, I try out stuff like this, and then, you know, we're going to see through experience. So first of all, through my own experience when I am writing this relatively large and complicated program in it. And then secondly, you know, as the circle of people who use it expands, we'll just see how it hits people and if it causes problems. So I'm going to have a very reality-based approach of, does this cause problems or not, right? So we'll see. How do I deal with distractions when programming? Don't get distracted. Tyler says, coroutines specifically get rid of the bugginess of it. By it, I think he means doing something complex over many frames. By making it 100% deterministic, whenever you tell the coroutine to go, it pauses the main thread and has the coroutine run until it hits yield. Then the main thread resumes. It's not useful for performance reasons. It's there in Unity for gameplay reasons. You can spread out one function across multiple frames very easily. It's useful for animations and enemy behaviors and cutscene scripting. Well, for something like that, I think you already could build that today in the standard library, because it's literally like, if you're satisfied with the performance of, hey, there's two threads and one of them launches the other one until it goes to yield and then waits on it and then continues. Yeah, you could do that today already. And then someone just builds a nice interface for that and makes that a library. So if that's all that you want, that doesn't need to be a language level feature. It's like if it's not in a separate thread, literally, if it's more like, you know, doing long jump style stuff where you're sharing your own stack and whatever, then it starts needing language level features. But if I support long jump anyway, then maybe you can just build it with that anyway. You could build fibers or whatever. We'll see. I'm not convinced that it needs a language level feature, I guess is what I'm saying. And in fact, it's often better to let people do it at a higher level if it doesn't need to be at the low level, because you know, there's more flexibility there, and you want the compiler to be as simple as you can make it. So, you know, it's good not to build too much in. What's the worst language feature I've ever encountered in a language? It's a tie. No? Okay. The worst language feature is the one that all these languages have. All these non-statically compiled languages have, where you typo a variable name in the middle of your code and you don't find out until you hit that during runtime. That's the absolute worst thing. As seen in Lisp and JavaScript and Perl and whatever else. And the reason they do that is because maybe you'll bind something to the global scope that has that name, but no, yeah, it's a terrible idea. The second worst language feature is exception handling as seen in C++. By far, that's terrible. Terrible thing. Terrible. Does that mean that I think I've said all I can say on the subject of coroutines. All right, that is all the questions, and I'm tired from answering questions today. I don't know why I'm so tired today. I just am. Does anybody have a really burning final question that they need to ask, or are we done? Lisp isn't a scripting language. Can you elaborate on why exception handling is a bad feature? I haven't heard this rant yet. I need to do this rant formally sometime. I'm too tired to give you the full explanation right now. I just argued it with someone in email last week or something. But the point is, exception handling has almost no upside, right? The one benefit of it that people say is like, oh, I could, or two benefits, is like, oh, I can return errors, you know, up many levels of code without having to handle it at each level, and then I can force people to pay attention to the errors, right? And the second one is not even true, because everybody just sloppily catches everything because they just want their code to work, so they just flail at it, right? And with error return values, you can have a much better way of forcing people to pay attention to things. A long time ago, we demoed this must keyword that you put on return values that says the person has to at least receive this return value, right? So there's that. That part of the argument is no good, right? And then in return for the other thing, so I've been programming professionally. Let's say strictly professionally for 21 years. And I've been programming amateurly. Oh my God, do I even want to do this calculation? I've been programming amateurly for 35 years. And I have never had a situation where I thought it was onerous to return error codes up to the previous scope. Like, I think if you have that problem, then maybe it's because you're buying into a style of programming that is excessively about glue code and useless abstractions and stuff anyway, that's going to have all sorts of other negative impacts, like, you know, hard to understand call stacks and long compile times and all that stuff, and runtime impact and things. So there's all that, right? But then the really, really bad thing about exception handling is it puts landmines all over your program, right? You don't know what's going to happen anywhere. And you have to write all your code. You have to try to write all your code in this silly C++ RAII way, which, by the way, makes your program very slow. And that's a nuanced thing to explain, but I've tried to explain it before. It makes it slow and bureaucratic and cumbersome and hard to understand, and it's still not correct. So if you have not tested your program's ability to react correctly to all the exceptions that you think you handle, which nobody ever does, then your program's probably buggy. Because as always, if you don't test it, it probably doesn't work, right? It is very, very hard for people to write exception-safe code. It's almost impossible for big programs. And even if you do it correctly, the burden that you take on of how many things you have to think about at all times is greatly increased, and it impacts your ability to write code. You're basically slogging through mud all the time. And for what benefit are you taking this huge, onerous, terrible penalty, right? Oh, well, for the benefit of sometimes I can return an error code up several levels of code. Like, what? Are you serious? You're going to like reduce your ability to see what your program is doing. You're going to add this fog everywhere, or like make it like you're, I don't know. Analogies are not coming to me, but yeah. Anyway, so there's this book, which I'm reading right now to my great amusement, because I want to know like what this Stockholm syndrome is that hits people. And so I'm reading Exceptional C++ by Herb Sutter, right? And there's these chapters in here about writing exception-safe code, right? And they're sort of written as puzzle things like, aha, I bet you don't see what's wrong with this code and how it's not exception safe, and I bet you can't figure out what you have to do to make it exception safe. And it's bananas. You look through here at these examples, and like by the time you're done reading these examples, the conclusion a sane person should come to is like, I am never using exceptions. I'm turning those off in the compiler, right? But somehow the C++ community thinks this is okay and thinks this is worth it. And it's not. It should be obvious to anybody. You read these chapters and then do any kind of basic cost-benefit analysis of what is the benefit that I'm getting for all this cost. And the answer is hardly any benefit, almost none. So it doesn't make sense. And that's it. Do I know how anyone who programs code that has to work, what they do instead of exceptions? Well, first of all, if your program has to work, then it's less likely to work if you have all this exception handling. Because like I said, you're not testing all your exception cases probably, right? Your code is more complex if you do exception handling, right? If your code has to work, you probably do something like what NASA does, all right? So now NASA, okay, let me postface my exception handling rant by saying there is a kind of exception handling that I'm fine with, right? It's not the C++ style of like you casually throw, right? The kind of exception handling that I'm fine with is like, oh damn, somebody did something bad and we have to somehow recover and gracefully exit the program, right? So like, oh, someone dereferenced a null pointer and we didn't expect that, or something like that, right? So the kind of exception handling that's okay is there was legitimately a bug in the program that we did not expect when we shipped it, so we're trying to somehow recover from that bug. That is different from the C++ style, which is, well, exceptions are like anything that isn't the normal control flow path. That's garbage, and it's terrible, right? It might be less garbage and terrible in a functional memory-safe language, but it's terrible in an imperative language like C++. It's ridiculous that they even think it's reasonable. I can't go far enough about this, right? Anyway, so, you know, what somebody like NASA does is they have they have various approaches, right? They'll like have things computed in triplicate by 3 different code paths. So if a cosmic ray hits one of them and flips the memory, the other 2 will disagree, and then there's a voting algorithm, and then that makes it work, right? Like, if you want to write code that really has to work, look at what the people in the real world do who write code that really has to work. And it's not the C++ exception handling stuff. It really isn't. It's other stuff like that. And that stuff I'm fine with, right? And the character of that is different, right? The character of that isn't, oh, I'm going to catch all the time random different exception types at different parts of my program. It's usually like, okay, we've got a global handler or a handler for this whole giant section, and it's a crash handler, and it helps us exit and restart correctly. Because once you throw, the invariants in your program can be all messed up. Like nobody frickin' knows what they are. So actually, maybe Abner can do a stream on like what JPL does on things that totally have to work or whatever. That would be informative. I would watch that stream. Okay. Will I be switching custom iterators from that iterator make into the iterate visitor style? Probably I will be switching it, but it probably won't be exactly the visitor style. It'll probably be something a little different, but we'll see. I have to figure it out, which is why I'm not talking about it yet. What are my current plans for iterating over binary trees? I mean, what do you want to do? Like, you could make a custom iterator for that if you wanted to, using the kind of thing that I demoed in the iterator demo many months ago, except refined for the more concise thing that I'm going to do. Or you just write plain old code that navigates the binary tree. I am a big fan of plain old code. So don't be afraid of plain old code, man. That's all I'm saying. That's all I'm saying. Yeah, I'm going to take a rest. I don't know why I'm so tired today, but I am. Thanks, everybody, for coming by. This will be up on YouTube if you missed part of it. And like I said, I think the next demo will be in substantially less than a month, but we will see. Thanks for coming by, and I'll see y'all later.